I think you all can see the screen. Can you all see the screen?
Yes, madam.
Thank you. Then the protein and protein functionality. Now, under the principles of food science, you have learned about the protein and not much thing, but you learn about some functions of the proteins. But because of this functionality or this behavior of the protein, you will end up with the different type of food products. So see this picture in the left hand side upper picture is the top picture is there are some raw material. You can see the eggs are there, peanuts are there, legumes, see some dal, cereals, and what's the meat, red meat, chicken, as well as the fish. Different type of proteins are there, right? And but in the other pictures also showing a different type of product by showing, but these products are based on protein, but not similar to the whatever the things you can see in the first picture, right? So so anyone can answer what is the left hand side, sorry, right hand side, the top one, what is it? Under your PFS, even you know what is it, but what happened to that that product? The eggs rolls are there, but later on you can see the bullseye, but it's different. So what's happened to the protein? Anyone can answer through the chat even. How you can explain these changes? Protein has denatured, right? Protein has denatured. So when it's denatured, when protein denaturing situation happen, then proteins are coagulated. So what kind of changes you can observe in these two pictures? Now normally you have some idea about what is the inside raw egg. That means once you broken the egg and keep it in the cup, you can see it's a colorless white frame and the yellow ball inside the or the middle of the egg. So what happened here? But colorless egg white changed to the white, white and solid situation. So what happened there? Anyone can answer? So before I naming you one by one. Anuradha Viswajit. Anuradha Viswajit. So give me some answer. What is removed from the
Please, madam, please, madam, may I tell a question again?
අහගෙන නෙමෙයි හිටියේ අනුරාධ. So the question is, now you can see that the egg white is there, right? Earlier egg white is a colorless one, but now it is a white color one. Then what happened to that egg white? How it came to the white color one? Why, from your the knowledge about the food chemistry or the principles of food science or the chemistry or whatever the general knowledge, you can answer my question. Anyone can answer. But I ask basically from Anuradha. What was removed from the system, what is not removed from the system. You කියන බොරු. Manimaran is not a correct answer. What was not removed from the system? Egg එකක් හදද්දි water අයින් වුණාද? A lot. Have you seen it? Hmm? Manimaran. Manimaran.
Madam,
Yeah.
madam,
Yes.
I think that because of the uh, provide of heat, the protein molecules, the structure of the protein molecules changes. So with the heat supply, um, it becomes denature and change the structure. So it will leads to this white color structure. Can it be?
Right. So now you can see a white color, right? So the earlier is a colorless. Now white color means you can see some color of that. The color means what will happen to the color actually. Color, how you can see the colors, because if there is a because now the especially in the case of yellow color, carotene, there are double bonds and therefore the light is absorbing by this product from the molecules. So that is why we can get it, we can see it as a color. And similarly, now here in the because of the now protein denatured. Now protein denatured means something happened to the protein, because the bonds are broken and therefore new bonds will be developed, and thereby the structure will be changed. Therefore that the nature will be changed. The water is not removing in this situation, maybe a little bit water, but totally much water is not removing. When you prepare the bullseye, you just heat the pan and put some lipid to margarine or oil or something, not to paste or the attach or the to the bake to the pan. That's all. It's there is, and also you need get much heat by adding some lipids, because lipid is trap some heat. Therefore, your egg will be boiling or the boiling very soon. That's why don't think about the lipid action there. There is no more action there is no action with the lipids. But in the case of heat, that the protein denature will be happen. But you can prepare the bullseye by a very few minutes, right? 1 or 2 minutes maximum is needed. And there the water is not removing. What is actually Manimaran, here the water is trapping. What is trapping with the water, with the protein molecule trap the water. That is why you can see that the very flexible and how we can say that once you touch it, even it's a coming back. That means a very spongy nature of the egg is coming, because the water is entrapped there. Even when you boil the water, boil the egg, the water is not removing because the shell is there. The water is not removed from the egg. So the water entrapped by the denatured protein, that is why you can get the spongy nature of the egg, right? Manimaran, have you understood?
Yes, yes, madam.
Right, okay. Therefore, thinking more logically, right? But it's good to answer, because I like it, because once you answer like that only I will be able to explain that point. That is why always the wrong answer is a kind of a blessing for us, because then madam will be explaining you what is going on. If you are not giving any kind of answer, then madam think, okay, you know all the thing very correctly, then she need not to explain. Right? Okay, let's back to our thing, our lecture. Then you can see that but in the case of egg, it's a yellow part of the egg, and it's as a yellow part, but it takes much more time when compared the egg white, the albumin part, egg white, to make it a solid one, right? Normally when you cook even, so you can see the egg part, the yellow part is not getting very quickly regulate compared to the white one. because white one is having the water and the protein, but in the case of the egg, yellow is having not only the protein and water, but there are more other compounds, lipids also there, as well as the different vitamins are there, different pigments are there. That is why it is not a pure one like a protein and water. That is why it will take more time to get coagulated. Right. So in the case of other one, that is okay, the protein coagulated and it's trapped water, and at the water now it's trapped the light, and therefore we can see it as a white color. Right. Later on we can understand it more. Then when it come to the kisses, right? Kisses, so some kind of a cream, whipped cream, and you can see it's a kind of a, let's see, puff one. The other one, left hand side, bottom one. Then let me know Eins, Asinsala. So what is it? Can you understand? Anyone can, if you can identify the product, can you explain it? What is it? What kind of product is that? Am I use the same pictures for the PFS? Anyone can answer? Amaki? Geetma? What is your answer? Amal ki Geetma. Solid form, right? Solid form, and now you know the form means the air form means the always whatever the form is entrapping air. The soap form even entrapping air with the soap, right? And this is foam and it is an entrapped air. So how that protein can entrap air? Because protein has the ability to make a structure to entrap air when we by during the denaturing. Earlier in the case of egg, it's entrapped water, but in this case it's entrapped air. Now we know that therefore the protein structure is having a kind of ability to entrapping air or water, or in some cases it may be able to entrapping lipids, but most of the time. So we are discussing these two, but protein also, in the case of some other products, it can entrap the lipid. So therefore the protein is able to entrap whatever the thing during the denaturation. The other one is the yogurt, right? Liquid yogurt. So can Chamudi Udavatta, Chamudi, can you explain it, what's happening in the yogurt formation? Chamudi? Chamudi Udavatta. Uduvaka, sorry. I wrongly pronounced your name. No, answer me quickly. Fermentation of milk, right? During the fermentation, what will happen to the milk? Fermentation means you are changing the pH, right? The first one, changing the pH, right? Change in pH, what kind of support we give to make it coagulate? Because we know it's a milk. Earlier there was a milk, and then due to the fermentation, so it make a coagulated one, and once you in relation to the whatever the adding inoculum or the bacteria, what you are going to introduce to that, then you can get this smooth texture or the different texture, flavor, and the taste of the yogurt, right? Therefore, and also you can add some sugars and the kind of thing, then you can get this kind of a stirred yogurt, right? And now it's a correct. Now let's go to the other one is the meat, the sausage, right? Let's see from whom I can ask the question. Right, let's ask from the Angel Pereira. Angel Pereira, what's your answer? What's going on? What's happening with the sausage? When you prepare the sausage, what will happen to the protein? Yeah, the sausage means not only this picture showing that the cooked sausage, right? Not the uncooked one. Yeah, thank you, Prashani. Anyone can answer Angel Pereira. I asked the question from the Angel. You can chat the Angel. If not so, you can answer it by using the voice. Thank you, Prashani, for your more explanation regarding this one. When preparing the yogurt, when preparing yogurt, fermentation happens, the lactic acid is produced, then pH reduced due to the lower pH, protein will denature. Right. The next answer for the other one, Angel, it get coagulate and entrap water and lipids. Right. And entrap water and lipids coagulation due to the what? Due to what is the reason here, Angel? Write the reason. It's entrap the water, it's correct, because of the high temperature, correct. And Fatima mentioned that the water binding ability is increased and juiciness is increased in sausage, right? Water binding ability is increased and the juiciness of increased in the sausage. Now let's compare these four answers. What's happening in these four pictures? The first one is we introduce heat and thereby we change totally the egg to this kind of product, and the white color and the yellow middle, and it's a softened texture and softened, and also the very spongy nature we got from the egg. But at the beginning it is a kind of a liquid one, but now it's a solid one and having a spongy nature. In the other one, here the first one we use only the heat. In the second one, you trap the air within the denatured protein by using the mechanical pressure. You are giving a mechanical pressure or mechanical agitation, or you are producing some energy. Therefore, only you will be able to entrap the air in surrounding the protein molecule. In the next one, when we talk about the yogurt, then in the case of yogurt, what you do is you reduce the pH, right? You reduce the pH and thereby you will be able to coagulate or denature the protein and again make it a coagulate and come with the nice flavor, texture, aroma with yogurt, right? In the next one, when we talk about the sausages, now what's going on? So here also the protein support to entrap water and lipid, as well as by at the beginning when we preparation the mince product, the raw yogurt, raw sausages, but later on once you boil it, you will be able to trap everything together and make a very spongy as well as the very nice texture of the sausage. Now here you can understand that we use the different type of techniques. When we preparation of the sausage, even you use the mechanical agitation or the mixing and then heating. But in the case of first one, only the heating. In the case of yogurt, you reduce the pH. In the case of the kisses or the kisses, so this form, and you use the mechanical mechanical mixing, mechanical pressure, right? So now you can understand basically by in different situation you can change the function of the protein. So what are those? If you have Buddhika given Gaveshani, Buddhika Gaveshani, type here in the chat what are the actions we have used here to change the protein. Buddhika Gaveshani, type in the chat box to everyone, or you can tell me. Buddhika, are you there? Buddhika, are you there? Increase in temperature. What else? Increase in temperature. What else? Fermentation and mechanical agitation. Right, good. And temperature changing. We can say the fermentation, you can say it's a lowering pH. Right? In the mechanical agitation. Therefore, now you can see that the three things are using here to change the protein, and accordingly protein functionality will be changed. Right. Now, in the case of dal, or in the case of wheat flour, in the case of meat, in the case of fish, everything, this is the thing happening. Right. Then let's think about from the beginning, where do we find food proteins? So there are some animal sources we can get the food protein, for example, meat and egg, and so these are the animal sources. Sorry, different type of animals, or the fish, or the animal milk, or the egg. These are the proteins come as animal sources. Then the plant sources is a legume, or the some cereals, or some yams, or the all kind of things is having the some amount of protein. But basically there are some the legumes especially, or the some cereals are having higher amount of plant protein. And also single cell, some bacteria and single cell unicellular is having also protein. We call this what's unicellular, what's the name? Different type of not those are not the bacteria actually. Is showing a single cell things it's giving the protein. I'm not remember the name now. So therefore the food composition of the will be changing according to the availability of the protein, water, lipid, and kind of thing. But meat, poultry, and fish are having having high protein content, and the fruits and vegetables are having low content in protein. Accordingly, when you are going to prepare any kind of product using the meat, poultry, or the fish, or this milk, or the egg, by using these things, those things are behave differently with the fruit, vegetable, and low protein content. For example, let's think about the fish. But if you boil the fish, or if you are boil the egg, it is having a different spongy nature and a different kind of texture. And but in the case of if you are boiled the egg or the vegetable, you can see it's a soggy nature, and it's a breakdown to all the things. You are not getting a kind of a solid structure. If you are if you are introduce heat to the fruits or vegetable compared to the meat, poultry, or the high protein thing, right? Therefore, accordingly, that the protein will be, you can understand that protein will be playing a big role in relation to producing these kind of actions, right? The other case is food preferences and sensory attributes. In this case, Sensory attributes are net effect of complex interaction of component of the food. Proteins give great influence on sensory attributes of a food. Am I correct or not? So the sensory attributes always net effect of complex interaction. In the case of that, the egg or sometimes with the what is the milk, or let's say the wheat flour, or different type of products which are having high protein content, giving a different sensory attributes compared to the low protein components, right? Therefore, in the other case, let's see now in the meat even, when you prepare the meat, let's say the chicken, the fried chicken, cooked chicken, and the sausage, the three different situations produce different sensory attributes. But when we prepare the fried one, cooked one, or the sausages, so what are the things we are doing there? In the case of sausage, you make a minced protein, make a blended protein, or the minced protein, or mechanically it gives some change to the protein, and finally later on you introduce the heat. In the second one, cooked one, you are introducing the heat as it is. Then two different structure, or two different nature, or two different sensory attributes you will experience by changing this situation. In the other case, in the fried one, if you have fried the chicken or fried the meat, so you can get some hard crust, but inside the juiciness of the meat, and also give a different type of different kind of sensory attributes, or sometimes you may like it. You like it more compared to sausage and meat, because what is happened there, when you are when you are frying the meat, whatever the water inside the meat is going out, and lipids is going inside, and cover or the filled by the lipids compared the water, and water is getting out. But protein is there as it is, as a fibrous form, and you can and some water also inside the product. Therefore, you can get the because of the Maillard reaction, you can get the very nice crust, flavor, aroma, and the appearance of the fried meat compared to the boiled meat, right? So when you know that in the case of boiled meat, definitely it's not supporting the Maillard reaction is supporting the giver crust, but in the case of other one, boiled one, you are not getting such kind of thing. In the case of sausage, during the fried even, that you can see that the nice color and the hard texture, hard covering in the surrounding sausage, also given by the Maillard reaction. So likewise, that you can food preference and sensory attributes are having a very good linkage, and to make it that the protein is playing a big role. So under this section of the protein and protein functionality, we are going to learn how these are working in that field. Now a few examples, apart from the example I have given earlier, there are some examples listed here. Here, let's see one by one. Viscoelastic and the low forming properties in the bakery products, action of wheat gluten. So you know that if you are going to prepare a bakery products by using wheat flour, and if you are going to prepare the same thing by using the rice flour, you will end up with the two different situations, or two different products. You can't get the same texture, or the same flavor, or same appearance, or the same aroma of the product once you prepare it from the rice flour when compared to the gluten or the wheat flour. So what is the reason? So how the structure is formed in the bakery products? It's totally, you know, that is depend on the protein or the wheat gluten in the protein in this product. But the rice is not, rice flour is not having, or another legume flour is not having the wheat gluten. Therefore, you are not ending up with this kind of a nice structure, nice inside the porous nature. You can't get there will be a porous nature because you are adding some leavening agent, but such a very spongy nature you can't get, because rice flour is not having a wheat gluten gluten component or gluten. Therefore, the rice flour can't make such a nice structure. Therefore, the viscoelastic and dough forming properties is given by the protein in that wheat gluten. The other one is textural and forming properties. The textural and forming properties, curd, whipping cream, because of the action of casein. Casein is a kind of protein, and therefore this protein is provided the textural and forming properties. In the whipping cream, basically it will be able to entrap the air, but in the case of curd is entrapping water and giving the very nice texture. Right? The other one is water binding properties of the structure of some cakes. Because if you are preparing the cake, even because that is structure, so the structure, even that structure, the porous structure can entrap the water because of the protein. When we learn about the protein structure, you can understand how these proteins are binding with the water molecule with hydrogen bonding. And therefore that the cake structure, cake or whatever the bakery product structure, you can get very nicely, especially in the case of cakes, you are adding egg white or the egg. Therefore the protein content increase, and therefore it's also supported to prepare that nice structure and the very moist flavor or moist texture to your the smooth texture to your mouth. The other one is forming properties. Dessert products, due to the egg white protein, the forming properties is there. That is why it can be able to entrap the water. Therefore, the forming properties is increase in the different type of products. For example, in the pudding or the watlapang, you can see that the forming property, because it is forming means it's not a very breakable forming, because form is there, but it's a very solid, because it's all because of introducing heat, you stable that the structure. So that is why you can get the this form product. Very nice texture is there. The textural properties again: meat, muscle protein, actin and myosin and actomyosin. These proteins are available, and thereby you can get that the very spongy nature of the meat and muscle protein once you heat it. Right? Not even heating, before heating even you can get that structure of the meat because of that the actin, myosin, actomyosin. Those are developed because of with the protein. Because with the protein, those are the basically proteins are there. That is why you can get that the textural properties of the meat and meat related products. Accordingly, we can describe, I think under your the principles of food science, even you have learned these things and you have answered very well your this equation. Therefore, I know that you have some very good knowledge about the protein functions. Function roles of food proteins in food system or food matrix, we can explain like that. There are some functions we can list out, like a solubility, it means soluble ability of the protein, elastic or viscosity, or make a thickness, and the thick fluid means not a water here, thick fluid or a thin fluid can make because of the water, because of the protein. The water binding ability is there because of the protein is having the water binding ability, gelation ability, cohesion adhesion ability, elasticity ability, emulsification ability, forming ability, fat and flavor binding ability. So there are the 9 things we listed here, because these abilities are there for a protein molecule. That is why accordingly that this function is providing this solubility ability function is producing there because of the hydrophilicity of the protein. The viscosity will be, the function is given by the water binding, hydrodynamic, size and shape of the protein, give that the supporting for the viscosity function. Then the hydrogen bonding, ionic hydration ability of the protein is giving the water binding or supporting for the water binding function. Water entrapment and immobilization, network formation ability of the protein give the gelation function. Then the hydrophobic, ionic and hydrogen bonding ability of the protein give the cohesion addition function of the function to the product. Then hydrophobic bonding, this disulfide crosslinks is giving that the protein is having this ability, is giving to the elasticity function of the food matrix. Adsorption and film forming at interfaces, that ability of the protein give the emulsification ability or emulsification function to the product. Interfacial adsorption and film formation ability of the protein give a forming function of the product. Then hydrophobic bonding and entrapment of the protein, that mechanism is producing the fat and flavor binding function to the product or the function, because now you can see these kind of all the mechanism means it's a ability. Mechanism means the what is going on, what kind of action is going on with the protein, because this action will be happen, this action, these activities, the protein can be participate for these activities. That is why it produces this kind of a function to the product, right? So now you can understand by listing functions are the functions are coming because of the, we call the function because thinking about the product, but mechanism we are talking about the mechanism because different abilities having with the protein molecule. Therefore these as the protein, whatever the protein is having, most of the thing according to the different, because you know that the protein is producing different using the different amino acids, but according to the level of amino acid or the amount of the amino acid in that protein supporting for different kind of function. Right. So they keep in that in your mind, and we are going to study in detail about this protein later on this module. Before I discuss about this kind of function, I want to remind you about the protein structure again. So the protein are made of 20 amino acids linked by peptide bonds. Polypeptide's backbone is the repeating sequence of the NCC in the peptide bonds. The side chain or R group is not part of the backbone or the peptide bond. That means earlier it's a recording is going on, Madhav, right?
Okay, madam.
Can you see the slides? Yes, right, sure. Madhav?
No, madam.
You can't see the slides?
No, I can't see.
Now it's okay, right?
Yes, okay, madam.
Right, thank you. And all amino acids have the same general structure, but the side chain R group of each is different. Therefore, this is the basic structure of the amino acid. You can see the R group is there, and R group can be changed hydrophilic, it's according to basic, acidic and uncharged, and hydrophobic, or sometimes the R group may be the special one. Accordingly, that because the protein means not one amino acid, there are the lot of amino acids. Therefore, that accordingly that action of this protein or the function of the protein can be changed. For example, if the R groups are hydrophilic one, then definitely that amino acid having proteins are showing a basic, acidic or non-charged one. If it is the hydrophobic, then it is not happy with the move with the water. Sometimes there are some special situations, special amino acids, special R groups can be there. Accordingly, the action can be changed. Let's see in detail about that. Here that the basic amino acids, you can see, we can, I think you have learned this under the principles of Utsan, right? How you remember? Okay. So the lysine, arginine, or the histidine is having the tail is a basic one. It's a more support for a high pH level, right? pH, 7 is the neutral we normally take, and if the amino acid is having these more lysine, arginine, and histidine, then these proteins are showing it's supporting for a high pH level. Then basic amino acids. Then basic amino acids. So you can break down the amino proteins is having basic amino acid. You can break down that they will denature that protein when you are changing the pH to lower level. So if the acidic medium, these proteins is having basic amino acids are coagulating, right? It's some kind of idea you can get it, but it can be changed because we can't say that the protein is not on the lysine amino acid, not is having lysine, not is having arginine, not is having histidine, or not is having these kind of things. It's a mixture of different amino acids. In there, so it's the acidic amino acids are the aspartic acid, and glutamic acids are the acidic amino acid. And definitely, if the protein is having a much aspartic acid or glutamic acid, you can change, or you can coagulate this, or you can denature this protein by changing the pH to the basic level. So if you are going for if you are any sodium hydroxide or potassium hydroxide, or if you are make a medium as a basic one, then you can calculate that or denature that protein. There are some other polar amino acids with uncharged R groups, and for example, serine and threonine, those are having the polar amino acids, right? Therefore, it's these groups are having polar amino acids. It's very happy to making a hydrogen bond, because you can see the OH groups are there. Therefore, they're making a hydrogen bonds, and therefore the water solubility can be increased by having serine and threonine. Other one is aspargine. Aspargine also the having polar amino acids. You can see that the aldehyde double bond O is there. That means definitely it's earlier the OH is having the H group can donate, but the O it's can also bind with the H, because O double bond O can donate electron, and therefore can make a hydrogen bond in the, because those are polar, because that is why you can get a very water solubility, or solubility of the water will be increased. Solubility means a binding, water binding ability is increased if you have the polar amino acid. Not only the water, but a different type of the polar, whatever the molecules can be bind with the these amino acids. So accordingly, the hydrophilic amino acids are support for by making a hydrogen bonds a lot. In the same situation, there are the hydrophobic or the special amino acids. So alanine, valine, isoleucine, leucine, likewise, those are the hydrophobic amino acids. So therefore, you can see that this tail is ending up with the aliphatic or the aromatic compound at the end. The first one is CH3, and the second one is again the another CH and CH3. Likewise, those are the aliphatic one. Therefore, those are not supporting for making a hydrogen bond. Those are the hydrophobic. It's a hate water. Therefore, the water solubility of these hydrophobic amino acids are very less. That is, therefore, it is supporting for binding with the lipids. Therefore, the protein, now you can see in the protein is having the hydrophilic amino acids as well as the hydrophobic amino acid. Therefore, protein can act as can join with the water as well as the lipid. That is why in some protein where we use some protein as emulsifiers in a food matrix. I think you know what's the name of the emulsifier. Emulsifier is having a +1 and plus head and phospholipids. Plus head and the minus, or the negative and the positive, both head and tails are there, therefore phospholipids can be act as emulsifier. And similarly, protein also can act as emulsifier, because protein is not a one type of amino acid, it's a combination of amino acid. If there are hydrophilic and hydrophobic amino acids are there, then definitely hydrophilic one is in the protein, that amino acid is combined with the or the joined with the water, and hydrophilic hydrophobic amino acids having that can bind with the lipids. Therefore, the protein can act as a emulsifier. Now, if I ask the question, explain why protein can act as an emulsifier, explain why phospholipids can act as an emulsifier. So then you will be able to explain it by using these structures. You need not to explain a lot of structures, at least 2-3 structures you have to keep in your mind, because if you want to answer the question, so you have to know this situation, hydrophilic, hydrophobic, right? So, and how these things are supporting to make a food matrix. So the food matrix means not only the one compound. So food matrix is a kind of a combination of different components. The other one, special amino acids are there, the cysteine, glycine and proline. It's having a different, because you can see some sulfur is there in that structure, and in the other one is a different one. It's having not the aromatic, but it's a proline. So those are we call special amino acids. So cysteine, glycine and proline. So let's see what are the action of these special amino acids. But basically, we are talking about this hydrophilic and hydrophobic one in special case of our when we talk about the food matrix. There are, you know that there are 4 levels of structure determines the shape of protein: the primary, secondary, tertiary, and quaternary. The primary structure is it's a chain type structure. So only combined with the linear sequence of amino acids, peptide bonds are there. So you can see alanine, glutamine, valine, these things are combined with each other with the peptide bonds. We call the primary structure. And the secondary structure, there are 2 structures are there, alpha helix and beta sheet. The localized organization of part of a polypeptide chain, the alpha helix and beta sheets can be there, because not only it's not in the linear structure, but it's this end is joined with the in the protein, the amino acids the other end. So that is why it's giving a alpha helix spiral structure, as well as the this different other one beta sheet structure. Backbone hydrogen bonds is by using the hydrogen bonds, these ends are combined with other one. When it comes to the tertiary structure, the overall 3-dimensional arrangement of the polypeptide chain and hydrophobic interaction, hydrogen bonds, non-covalent bonds in the inter, and sulfur bridges can be there. Therefore, these amino acids or these primary structures can be linked with the other primary structures. Therefore, you can get the term tertiary structure. Right? So now you can see because first one is only the peptide bonds primary structure is there. Second one is the not only the peptide plus hydrogen bonds are there. The second one, it comes to the hydrophobic interaction, hydrogen bonds, as well as the sulfur bridges are there. Apart from the peptide bonds also there. However, peptide bonds are there. It's a common no. The other one is when we come to the quaternary structure, the association of 2 or more polypeptides into multi-subunit complex. Therefore, here that the more polypeptide bonds are into multi-subunit. The unit are there and all are get together. Sometimes these units are linking. The first unit is there, second unit is there. Those are bridging with each other with the sulfur bridge or the different type of thing. Therefore, the multi-subunit complex is formed here when it comes to the quaternary structure. It's a very complicated structure when it comes to the quaternary structure. It's very difficult to explain. When we talk about the peptide bond formation, so what will happen? one amino acid and other amino acid get together, and then it link with peptide bond, because peptide bond is formation after removal of the water. Then you can see these things get together. That is why the primary protein will be forming with removing one water molecule, another water molecule, another water molecule. Therefore, there are a lot of amino acids can be combined with each other and make a big, or the polymer type, or the very big chains of protein. So therefore, it's producing a linear chain, but like this backbone and also the side chains are there, because all amino acids is having R groups, R1, R2, R3 groups. These groups can be therefore it's not in a one plane. There is not a linear chain into a linear chain, but it's not in a one plane, because of the R groups are having a different size. Therefore, it's a very complicated structure at the end. So because of the side chain. Polypeptide backbones, again it's showing in this picture how these things are forming, and you can see that you can see the last picture schematic. Now I mentioned you that the different amino acids can be combined with each other using the polypeptide bonds. Therefore, when it draw a kind of a linear one, then the polypeptide bonds are bonding maybe non-polar, basic amino acid, then the acidic amino acid, or hydrophilic amino acid, or hydrophobic amino acid. Likewise, different amino acids can get together and make this complex structure. The importance is here is that whatever the side chain, that your side chain will be deciding the action of the amino acid. Therefore, now you can see in the picture that if there is a non-polar side chain, and the other one, blue one, is the polar side chain. Therefore, the non-polar, polar side chains having amino acids can be get together. Accordingly, that the protein will be able to connect with the polar complex or the non-polar complex, or it can link with the polar molecules as well as the non-polar molecule. That is why the protein can combine with the water, or the link with the water as well as the link with the lipids, because due to it's a polar and non-polar side chain, different behaviors can show by the protein. That is why protein is really important when we talk about the food matrix, because the role is really big compared to the water. Is a kind of it's a one type of molecule. It's H2O molecule, and it can be bind with the protein. Now you can see how it can bind with the protein. Accordingly, the protein can trap the water, or water binding ability of the protein is increased because of this different type of amino acid join with the acids are there in protein molecule. It's a sequence is showing the what is methionine, aspartame, leucine, and tyrosine. You can see how polar, non-polar, and polar ones are getting together by getting linked with peptide bonds. The side chains will help to determine the conformation is an aqueous solution. Now think that the unfolded polypeptide bonds are there. There are polar side chains in the blue color as well as the non-polar side chains in the green color. So when it's a hydrogen bond, therefore if the polar side chain and the polar side chain can make a hydrogen bonds, then non-polar one is not making a hydrogen bond, but that is why you can see in the next picture, hydrogen bonds can form to polar side chains on the outside of the molecule, and the hydrophobic core regions contains non-polar side chain inside. Now you can see all how when we talk about the emulsification means how these things are support for mixing with the or the trapped or the combine water and lipid together, because it entrapped lipid inside because of the polar side chain, and it combine or the link with the hydrogen or the water with the hydrogen bonds in with water by lipids can be entrapped with the non-polar side chain, and water can be linked with the polar side chain of the protein with hydrogen bonding. So now you can how these are folded conformation in aqueous environment, because normally unfolded polypeptides making a folded conformation in aqueous environment. Now you can explain it by this kind of a diagram very well. Then hydrogen bonds are in detail how hydrogen bonds in proteins. So here you can see orange color, hydrogen bond between atoms of two peptide bonds can be formed, right? Hydrogen bonds between atoms of two peptide bonds. The other one, hydrogen bond between atoms of a peptide bond and an amino acid side chain. If the amino acid side chain is a polar one, then again hydrogen bonds can form in the protein in between peptide bond as well as the amino acid side chain. The third type is hydrogen bonds between two amino acid side chains also can be formed. Therefore, you have to understand that there are hydrogen bonds can be formed in protein in the three ways. The one is atom involved in the peptide bonds and the amino group, R group, side chain, or in between R groups. In the three ways, hydrogen bonds can be formed in the protein molecule like this. Similarly, in the other one is non-covalent bonds in protein also can be there, right? That means ionic bonds. So the van der Waals attraction also can be there in the when it's a folding, because now different molecules also, different molecules can be close together because of the folding situation of the protein. You can see in the middle picture because of the folding situation. So the at the end of the curve, then some molecules get together. Therefore, van der Waals attraction can be there, or because of that the folding can be happen, and because of the folding, van der Waals attraction support for the folding. Also, because of the van der Waals attraction is a folding, then again the hydrogen bond support for strengthening this folding. And not only that, also ionic bond also supporting for strengthening this folding. Therefore, the folding can be strengthened by different situations: the van der Waals attraction, hydrogen bonding, as well as with the ionic bonding. Here in these two pictures in the left hand side and right hand side, you can see how these hydrogen bonds are formed in between the C double bond O and also the NH. These things also having the hydrogen bonding, and N and O may showing the ionic bonding, right? Not only that, there is a disulfide bonds also formed in the as a covalent bond. So I think I have keep this slide for you to fill, and you have to upload the assignments, today's assignment, that once you finish this lecture, upload that how that disulfide bonds are forming in the protein molecule, right? What is the reason? How is it forming? So therefore, this slide should be filled by yourself. Make a PowerPoint slide and then upload it to the LMS at the end of this lecture, right? Then when it comes to the protein folding, the peptide bonds allow for rotation around it, and therefore the protein can fold and orient the R groups in pairable position. So shall we stop this today's lecture now, Madhav? Because I think if not, the pipes also getting very big.
Oh, okay, madam. We can stop.